Welcome everyone. Today we're going to be discussing the graphs of quadratic functions. By the end of this lesson, you're going to be able to learn and be able to sketch the graph of quadratic functions in the form ax squared plus bx plus c, a times a minus alpha times b minus alpha, and then a times a minus alpha squared. Currently, in the last lesson, actually, that'd be previously in the last lesson, we discussed the graph y equals ax squared. So now we're just going to add on to that. Okay, so what we're going to do is pretty much take the graph that has the vertex at 0, 0, and then just move the graph around. A little bit of a translation to it, as we would say. So now, we can sketch the graph of a quadratic function by considering the value of a and whatever its axes of intercepts are. Okay, so there's two types of intercepts. The first type is your x, and the second type is your y, as we discussed previously as well. So, sketch the graph y equals x squared minus 3x minus 10 by considering the value of a at these specific intercepts. So number one, what does a equal here? Well, the graph is ax squared plus bx plus c, so a is whatever is before the coefficient of your x squared. Okay? Since there is no number here, we just assume that its placeholder is 1, because 1 times x squared is x squared, so a is 1. Now, is a greater than or less than 0? A is 1, and 1 is a positive number, so it's greater than 0. Okay, because it's greater than 0, because it's positive, remember what the shape is from the last lesson? Does it go up or does it go down? So positive a is a U shape. Not an upside down, but an open. It opens upwards, the positive. Right? That's part one. So now we know our graph is going to be opening upward. Part two. We're going to find our intercept. So in order to find the y-intercept, what you do is you set x equal to 0. So set x equal to 0 there and solve for y. What you're going to do is 0 squared minus 3 times 0 minus 10. 0 minus 0 minus 10. Your y-intercept is negative 10. All right, so that means when the x value is 0, your graph is going to cross the vertical y-intercept at negative 10. All right, sketching the graph means somewhere in the graph put a point and write negative 10 next to it. Not very difficult. The only thing you need to know about this is it has to be under the x-axis. In order to find the x-intercept, what you do is you set y equal to 0, because the x-intercept is where your graph crosses the x-axis, and the x equals 0 in all these cases. Now, you can have either 0, 1, or 2 x-intercepts per graph. Okay, per quadratic equation. So you're either going to have 0, 1, or 2. That's why you can have multiples. So when y equals 0, you set y equal to 0. 0 equals x squared minus 3x minus 10. So now what you do is you can do a couple things. You can use your calculator, which I'll show you to do in a second, or you could factor and solve that way. I like the factor because that uses a little more math and it's pretty easy. Factors of negative 10 that add up to negative 3. Because this is a negative sign, that means you're going to have a plus and a minus. Because this is a negative, that means your minus is going to be higher. 5 and 2. 5 minus 2 is 3. So negative 5 plus 2 is negative 3. Negative 5 times 2 is negative 10. You set both of these equal to 0 to solve for x. X minus 5 equals 0. X plus 2 equals 0. In order to solve for x, you add 5 to both sides and x equals 5. You subtract 2 from both sides and x equals negative 2. So the x-intercepts are negative 2 and 5. Or negative 2 or 5. You can say and or, it doesn't matter. So on your graph, negative 2 goes over here somewhere, and 5 goes 2.5 times as far down over there. As we discussed earlier, sketch shows the general shape and key features. So our key features are our two intercepts, and our general shape is an upside down U. So we know it's going to look like this. The reason 10 isn't our vertex, okay, we could tell we would make this a vertex if both sides are the same distance away. Because this one is 2 away, and this one's 5 away. We know this point, which is the vertex, has to be between the two. So it'd be somewhere around here, and you go down. And that's why that's my vertex and that's a negative 10. Right. There you go. Oh, it was simple. Ready for the next part? Alright, what I want you guys to do is, problem number 1, I want you to sketch the quadratic function with the following. X-intercepts that are negative 1 and 3, and a y-intercept of negative 2. So you're just drawing the intercepts on this graph that I gave you. And then you're going to draw the u based on where the intercepts are. If a quadratic function has only one x-intercept, then the graph just touches the x-axis. Okay, it doesn't go through it, it just touches it. So, 2, 2, 2, we don't have to worry about it yet. X-intercepts, negative 1 and 3. Y-intercept, negative 2. Okay, somewhere between these two, halfway is about here. So our vertex is going to be down here, about-ish, up a little bit. There's your u. Right? B and C. All right, B. Negative 5, 2. Y-intercept is 4. Okay, which way do you think it opens, up or down? Well, you can't go up or else you have to come back in. So obviously it has to go down. About halfway between 2 and negative 5. Let's go whoop, whoop, back here. So say vertex about here. There's my u. Right. 1 and 6. 1 and 6. Y-intercept, negative 7. Ooh, so which way do you think it opens, up or down? Down. Okay, if it opened up, what would it do? Can't do that. So it has to come down here. About halfway between the 1 and 6 is about right here. So I'm going to go about right here, maybe? We'll go all the way up here. And then get your u. All right, as long as you have it, the vertex is somewhere here, and going down through you. Right. You're just drawing the general shape of the equation. All right, let's go do D and E. D and E. It's on page 17, bottom right hand. All right, let's go check it out. D, only one x-intercept. If the quadratic has only one x-intercept, the graph must just touch the x-axis. So, x-intercept at 1, 2, 3. Y-intercept at 1, 2, 3, 4, 5. Now, it's just going to touch the x-axis. Okay, it doesn't necessarily go through the x-axis, right? So what you're going to do is, well, if it just touches it, it means it's either going to go u like this, or u like this. U like that. Okay? Same thing. One x-intercept, it must just touch the x-axis. So, x-intercept, negative 1. Y-intercept, negative 4. Which way do you think it opens? Up or down? You are correct, and it does open down. A, B, C, D, and E. All we're going to do now is move on to problem number 2. Now 2 is a pretty big problem. There's 9 parts to it. Sketch the graph of each function by considering the value of A and the axes of intercepts. So, now you're going to have to find the axes of intercepts. Where are you going to do this one? Fairly simple. Number 1, y equals x squared plus x minus 2. All right, now as I said before, A is what? Positive, right? So positive A means our graph is going to open up. So before we do anything else, we know it's going to be an upward U. All right, I can just put that. This is positive. I know it's going to look like that. So first thing I'm going to do is I want to find my y-intercept. Find my y-intercept, I set x equal to 0. Okay? So to find the y-intercept, you set x equal to 0. 0 plus 0 minus 12 is negative 12. So on my graph, I put a point down at negative 12. After you find your y-intercept, you're going to find your x-intercept. To find the x-intercept, you set y equal to 0. And we just did this before in the earlier example. So 0 equals x squared plus x minus 12. And then you're going to do this, and after you do this, you pretty much factor. All right, you factor and you solve for x. So factors of negative 12 that add up to 1. 2 and 6 is 4, 1 and 12 is 11, 4 and 3. X plus 4, 4 minus 3 is 1, 4 times negative 3 is negative 12. After you factor, you're going to set each one of these equal to 0. X plus 4 equals 0. And x minus 3 equals 0. Okay? Subtract 4 from both sides, x equals negative 4. Add 3 to both sides, and x equals 3. Right? Negative 4 and 3. Now, as I stated before, this is positive, so we know it's an upward U. And there we go. This is close to the vertice, but not exactly, because the vertice is more about over here. Right. Now we're going to move on to letter B. Positive A. Which way does it open? Opens up, right? Put my little arrows there. All right, so first thing I'm going to do is find my y-intercept. Set x equal to 0. The y-intercept is always the number, here's a hint, that doesn't have a variable attached to it. So it's just negative 5. Set that equal to 0. I'm going to solve for x. So 5 minus 1 is 4. X plus 5, x minus 1. 5 times negative 1 is negative 5. X plus 5 equals 0, x minus 1 equals 0. Subtract 5 from both sides and x equals negative 5. Add 1 to both sides and x equals 1. Point at negative 5 and 1. All right, vertice is somewhere around the middle of this. We know it goes up, so I'm going to say around right here. There's my U. You can always use your calculator to check your answer as well. Your calculator or your graphing package. All right, problem C. Ooh, negative. Negative A. So which way do you think that one opens? Because this is a minus, we're going to be opening down. Set x equal to 0. Y is negative 9. Negative 9 is my y-intercept. All right? Still pretty easy. It's negative 9 opening down, so it's going to be like this. Negative 9 is our maximum. Where's x? 0 equals this stuff. Now you may say, oh no, negative sign in front. Now watch what you can do. I could multiply both of these by a negative 1. If I multiply both sides here, negative 1 times 0 is 0. Negative 1 times this is x squared minus 6x plus 9. Now I get factor. I always want a positive x squared there to factor. Me personally, especially. 3 and 3. X minus 3 times x minus 3. Negative 3 is positive 9. Negative 3 minus 3 is minus 6. These are the same, so you only have to use one of these. X minus 3 equals 0. Add 3 to both sides, and x equals 3. So you have one x-intercept, and that intercept happens to be 3. Right? Now, since you have one intercept, it means your parabola is going to touch that line. So it's going to come through the 9, touch the 3, and go back down. And there is your answer. Nothing to this. These are easy lessons. They're short lessons, but there's just a bunch of them. It's a bunch of little rules that just keep on expanding upon each other. So now I want you to do D, E, and F. D, E, and F. All right, I'm going to assume that you guys have done D, E, and F. Okay, let me go through this. Oops, I got my parabola still here. Positive, so that's a U, right? just so you know what I'm talking about. All right? Set x equal to 0. Once again, it's just going to be this number. So y equals 16 is my y-intercept. This is positive, so it means the u is going to go upwards, outwards, right? Faces up. Set y equal to 0. Are there any factors of 16 that add up to 8? Yes, there is. 4. And 4 is 8. 4 times 4 is 16. X plus 4 equals 0. Subtract 4 from both sides and x equals negative 4. Y-intercept, that means it's going to touch it. So that is your, what? When it touches it, that's your vertex. Okay? Anytime you have one x-intercept, it touches the graph, and that place where it touches it is the vertex. Negative 4, 0. All right. Negative, that means open down. To find the y-intercept, watch this. It's going to be 12. You don't even need the other stuff. 0 plus 0 plus 12 is 12. 0, 0, always. Okay. Open and down, so we know it's going to be something like that. Let's check out our x's. Set that equal to 0. Remember what we multiply both sides by? You multiply everything by negative 1, right? You get x squared minus 4x minus 12 equals 0. 6 and 2. X minus 6, x plus 2. X minus 6 equals 0, x plus 2 equals 0. Add 6 to both sides and x equals 6. Subtract 2 from both sides and x equals negative 2. Negative 2 and 6. The vertex will be somewhere around here, so put it about here. Here. There's your u. Remember, your parabolas are always symmetrical. As well. All right, problem letter F. Once again, negative sign. 0, 0, 4. Y equals 4 is my y-intercept. We know it's going to be going down. Why is that so tall? That's weird. All right, so look what happens here, though. I get to this point, and I have to use the calculator. This is why. Even if I make this positive, and I make this, I'm just going to write this here. The reason I didn't do it because it's not going to work. X squared minus 6x minus 4. The factors of 4 are 1 and 4, 2 and 2. You can't subtract either of these to get negative 6. So this is not factorable via just splitting it up into two pieces. So you can do one of two things. You can use your quadratic equation. Ooh, negative b plus or minus square root, what's that? 4b squared minus 4a over 4ac over 2a. That big long quadratic equation. Or you can use your calculator. Now, upon using your calculator, you get x1 is negative 6.05, x2 is about 6.06. Okay, you get these two answers. If I put them on my graph, I get a parabola that looks like this. Because about halfway between these two is about 3. That's why it goes up, down, and down. Now you may say, wait a second, how'd you use that calculator? I told you before, and I'll tell you again. So I got my calculator here. All right, and I'm going to go, okay, I'm going to hit the apps button. I'm going to hit 9, which is PLYSMLT2. So go down to 9 and hit enter. Now my two favorite things are here, polynomial root finder and simultaneous equation solving. I want the root finder. All right, now 2, because it's to the second power, I hit next. Now I had one in here before, but I don't like that one. I'm going to use the one I have. I'm going to say negative x, so negative 1x squared, plus 6x plus 4. Okay, this is the equation that I was given. And then I hit the solve button right here. And when I do that, it gives me my answers. Negative 0.6055, 6.6055, blah, blah, blah. I go to 3 significant figures, and that's how I got my answers. All right? Nothing much about it. Pretty easy. And you could do that for even these, if you want to. If you're really lazy, will you get the right answer? Of course you will. Technology doesn't fail, but it's just better to do it this way. You can see things better, you have a better feel of how things work. I like it better and so on. Right? Will you lose points in debate? No, you won't lose points in debate. But it's just, I don't know, I just like doing it mathematical way, if you can. Okay, like this one I can kind of do the mathematical way, but using the calculator is easy. I'll show you. So first off, positive, so it's going to be an upward U. Plug in 0, you get negative 24. Alright? Now, if I set this equal to 0, I could simplify this. Now, what can I do to every one of those numbers in there? What's divisible by all these? 2. 0 divided by 2 is 2. 2x squared divided by 2 is x squared. X and negative 12. Now watch what I can do. What are the factors from negative 12 that add up to 1? 1 and 12, 2 and 6, 4 and 3. Bigger number is 4. 4 minus 3 is 1. 4 times negative 3 is negative 12. X plus 4 equals 0 and x minus 3. Oh, I made my first mistake. I thought I'd fix this. And x minus 3, x minus 3 equals 0. X equals negative 4 and x equals 3. Alright? One simple mistake. Negative 4 and 3. Okay, this is positive 2. It's going to open upwards, and there's my answer. If you want to use your calculator, yes, you'll get the same answer. I'm going to use the calculator for this one, even though I know how to factor it, but it's just quicker to do it that way and less mistakes. This one, that's a negative, so I'm going to open downward. Plug in the 0 to my y-intercept, just drop every single thing in my hand. Ugh. And y equals 9. Alright? Solve for x. 0 equals all this stuff. Oh, put 9 here. Now, I can't divide this by a negative 2 or anything, so I would have to factor this and have a 2x plus something, and then like an x minus something in order to solve this. It's probably something along the lines of like a 2x minus 3 and a negative x minus 3. Something like that. But I don't really feel like going through all those motions. So what I'm going to do is I'm just going to use the calculator, and I'm going to find out that x1 is negative 3, or x2 is negative 3, and the other one's 1.5. Now you may say, wait a second, how did you do that? Well, once again, I just got my calculator out. All right, I go, oh, here's my calculator. Cool. I go, oh, what was the button? Oh yeah, it's apps, applications. All right, I'm going down to 9 again, PLY-SMLT. All right, polynomial root finder. There's 2 because it's squared. I go, all right, what do we got here? We got a negative 2, x squared. Now it's a minus 3x, so I put the minus, change that to a minus. 3x plus 9. I go, cool. Let me graph it, and there we go. Negative 1/2. Oh wait, was this saying negative 3/2? 3. Well, mine. How come that's a fraction? That's a decimal. Well, I just hit this F to D, and I can make it fraction, decimal, fraction, decimal. I said that backwards, but you get the gist. Negative 3, 1.5. Okay, vertices about here. Negative, so it goes down. So I'm gonna go about here. There's my answer. All right. Negative. Gonna open down. Plug in 0. Y is negative 25. All right. Set that equal to 0. Now I probably can factor it. It looks like it should be like a negative 2, minus 5, negative 2 plus 5, something like that. But you know what? I'm going to my polynomial root finder. I'm just going to type in negative 4 plus 20 minus 25. All right. Get right to this situation right here. Go, well, you know what? I can just type this in. And I was typing it as I was talking to you. Hit solve. And then I go, oh, look at that. 5/2, 5/2. Told you it was the same thing. All right. You know what? I don't know what 5/2 is. Oh, let me put a fraction. 2.5 and 2.5. Let me put a decimal from a fraction. Let me put the fraction. Let me put the decimal. Let me put the fraction. Doesn't matter which one you use. They both are the same answer. All right, so I have decimals here. My answer is about 2.5 and 2.5. Since they're the same, that means there's only one x-intercept. That means it's touching. It means that's the vertice. And there's your answer. G, H, I. Okay, so that finishes problem number 2. Let me do one more type of problem. And then we'll do example 3 and 4. All right, for you, get rid of you, get rid of you. All right, examples. Sketch the graph. Boom. Oh, wait, now it looks different. The only difference here is now you got x plus 3, x minus 4, but it's not in the same form. It's already in factored form. Well, that's pretty cool. I like that better, don't you? Well, what's our A? Our A is the same thing. Our A is whatever number is in front of the two numbers that we're multiplying. Because look at x times x is just x squared. So negative 3 times x squared is negative 3. Negative 3 happens to be less than 0. Numbers less than 0. Negative numbers open which way? Downward. Okay? Anytime A is negative, opens downward. Anytime A is positive, opens upwards. Now when x is 0, we're going to find the y-intercept. Plug 0 in for both of those. Negative 3, 0 plus 3. 0 minus 4. 3, negative 4. Negative 3 times negative 4. Negative 9 times negative 4 is a positive 36. So the y-intercept is positive 36. Boom. All right. When y equals 0, right? That's your x-intercepts. You set this equal to 0. So we're just doing as we did before. This negative 3 doesn't matter. 0 divided by negative 3 is 1. So all we care about is the stuff in the parentheses. We just care about 1, 2. X plus 3 equals 0. X minus 4 equals 0. Subtract 3 from both sides. X is negative 3. Add 4 to both sides, and x equals 4. So your two x-intercepts are negative 3 or 4. Negative 3 and 4. So this isn't the vertice. It's almost the vertice. Vertice is around here. So I'll go like boom, boom. There you go. And that, my fair class, my very smart class, is your answer. Right, so click on number 3. You're going to do 3, A, B, C, D, E, and F. They're all very similar to this problem. So go, 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 and go. All right. Ready? Magic. I just got to find my... There it is. I'm looking for my rat. I couldn't find my rat. All right. Whew. Breathe. First off, A is technically 1, so we know it's going to open upwards, okay? So I'm just going to do the upwards down there. Okay, so this is A is 1, we're opening up. X equals 0, that's how you find the y-intercept. Negative 4 plus times 2, negative 4 times 2 is y is negative 8, so we put a negative 8 down here. All right? In order to solve for your x-intercepts, you set the y equal to 0. 0 equals x minus 4x plus 2. Set both of these pieces equal to 0. X minus 4 equals 0, and x plus 2 equals 0. Add 4 to both sides, and you get x equals 4. Subtract 2 from both sides, and x equals negative 2. Negative 2 and 4 you put on your graph. All right, graph opens upwards. Vertices somewhere between them, so about here. So you put like a point here, boom, boom. How do you find the vertice? I know exactly how to find it, but we're not doing that till another chapter, so hold off on that. That's why we're just sketching. I'm giving you all the different pieces to use, and then eventually we're just going to put all the pieces together. All right, problem B. What's A? A is -1. Since A is a negative right here, it's going to open downward. Set x equal to 0. Negative, don't forget that negative, 0 minus 4 is 0 plus 2. Negative, -4, 2. 4 times 2, all right? -1 times -4 is 4, times 2 is 8. So y is 8 is your y-intercept. All right? Find your x-intercepts. You set both of these equal to 0. X minus 4 equals 0. X plus 2 equals 0. This minus in front does not matter, because -1, 0 divided by -1 is still 0, so we don't care about that. We just care what's in the parentheses. Add 4 to both sides, x equals 4. Subtract 2 from both sides, x equals -2. -2 and 4. We know the graph opens downwards. We know the vertices somewhere between these two, about here. So I'm going to put my point about here, right? Oh, down here. There you go. The key is you have the intercepts listed, you have the graph facing the right way, and you kind of have an idea of where the vertex is, x-wise. The y of y doesn't really matter yet, because you're not supposed to know. See? Positive. Opens up. Set x equal to 0. 3 times 5 times 2. 15 times 2 is 30. So you put y is 30 up here, and we know that our graph is going to go up. Find the x-intercepts. 0 equals 2 times x plus 3 times x plus 5. X plus 3 equals 0. X plus 5 equals 0. Subtract 3 from both sides, and x equals -5. Subtract 5 from both sides, and x equals -5. Wait, -3, -5? Ooh, I don't even know if I said that. So you got -5, -3. Wait a second. Which way does this graph open? Opens up, right? So I said this before. I was really off. It has to go through this axis, right? So what's going to happen is the vertex is somewhere between these, right? And then it's going to go up and shoot to the 30, and up and shoot to the other side as well. Right. Woo. All right. D, E, and F. Sketch each function by considering the value of A and its axes of intercepts. Value of A right here is -3. Goes down. Now we're going to have to find the intercepts. Set x equal to 0. -3 times 1 times 5. -15. So we know this is -15. We know the graph is going to go down. We're going to find the x-intercepts. -3, x plus 1, x plus 5. Then -3 doesn't matter. Just these two matter. X plus 1 equals 0. X plus 5 equals 0. Subtract 1, x equals -1. Subtract 5, x equals -5. -5, -1. All right, so we know it's going to go down, so the vertex is somewhere up here. We're going to shoot down and go through the -15. Isn't this great? You guys can almost do these in your head now. E. Uh-oh, there is no A up front, right? But watch this. All right, you want some magic? 3x times that is 3x squared. So technically your 3 is your A, right? Which is a positive number, and positive numbers open up. See that? That wasn't too bad. Set x equal to 0. So, no number out here, so just -2 times 4 is -8. Put your graph for -8. You know we're going to be opening upwards. So it's probably going to start down here somewhere, down here somewhere. We don't know yet. Set that equal to 0. 3x minus 2 equals 0. X plus 4 equals 0. All right? In order to solve for x here, you're going to add 2 to both sides. You're going to divide by 3, and you get x equals 2/3. You're going to subtract 4 from here. X equals -4. So you got a -4, and you got a 2/3. 2/3 is about 0.67, 0.667. We're going to do 3 significant figures. Right around here is your vertex. So kind of around right here. Can't get it right. And then you go through. Right? Boom. How we go? We're trying to find A. We got a negative, a 2x, and an x. So A is going to be negative 2x squared. Negative numbers have downward openness. So x equals 0. Negative 2 times 0 minus 1 is 0 plus 2. Negative. Negative 1 and a 2. Negative and negative is a positive. 1 times 2 is 2. Alright? Next thing you do. Y equals 2. Set this equal to 0. 0 equals negative 2x minus 1, x plus 2. The negative doesn't matter, remember, just the stuff in the beside the parentheses. Hopefully this is sticking, me saying the same thing over and over and over. 2x minus 1 equals 0, and x plus 2 equals 0. Solve for x. Add 1 to both sides and divide both sides by 2. X equals 1/2. Subtract 2 from both sides. X equals negative 2. 1/2, negative 2. Opens downward, so our graph looks something like that. All right. Last but not least, example number 10, the third type that we were talking about, A, x minus alpha squared. So, if you only have something like this, you solve it using the same exact method. What is A here? Still the number up front, which is 4. 4 happens to be a positive number, which is greater than 0, so our parabola opens up. Same way we solved it. Find the y-intercept. So when x equals 0, same way, plug 0 in. F of 0, 4 times 0 minus 2 squared. 0 minus 2 squared is negative 2. When you square a negative number, it becomes positive. So 4 times negative 2 squared is 4 times 4. 4 times 4 is 16. Y-intercept 16. Find the x-intercepts. That's when f of x equals 0 and y equals 0. So 0 equals 4 times x minus 2 squared. Now when you solve for x minus 2 squared, you can divide both sides by 4 here. When I divide by both sides by 4, 4 divided by 4 is 1, goes away. 0 divided by 4 is still 0. So you just care about the stuff in parentheses again. See that squared? That doesn't matter. I can take the square root of both sides. And I get x minus 2 equals 0, where 0 equals x minus 2. Add 2 to both sides, x equals 2. Therefore, my x-intercept is 2. All you care about when solving these questions is you don't have to do all the work, you just have to set whatever is inside the parentheses equals to 0. Everything else cancels out because of 0. There's only one x-intercept, so the graph touches the x-axis. Okay, so it touches it, and that where it touches it is the vertex. So it's going to go here, shoot to that 16, shoot symmetrically the other way as well. Or travel, or go. Right. Whew. Last set of 3 problems. All right, this says 3. But this is really 4. All right, so first thing, positive. Open it up. Set x equal to 0 to find the y-intercept. 0 minus 1. Negative 1. 3 times negative 1 squared is 3 times 1 is 3. Y-intercept's at 3. We know the graph's going up. We know the graph is also going to touch the x-axis because there's only one x-intercept. So 0 equals 3 times x minus 1 squared. All we care about is the inside. X minus 1 equals 0. Add 1 to both sides and x equals 1. Put down a point at 1. All right, we know this is the vertex, so whatever you do to the left, you do to the right. All right, do the next and the last two, B and C. All right, B, positive, gonna open up. Set x equal to 0 to find the y-intercept. 2 times 0 plus 3 is 2 times 3 squared. 3 squared is 9. 2 times 9 is 18. That's your y-intercept. Find the x-intercept. 2 times x plus 3 squared equals 0. So we want to have this piece equal 0. X plus 3 equals 0. Subtract 3 from both sides and x equals negative 3. So at negative 3, my only x-intercept, I'm also going to have my vertice. Graph goes to the right, graph goes to the left, the same directions, creating my symmetrical parabola. Last one, negative 1/4. We're going to be opening it down. Negative 1/4 times 0 plus 2 squared. Negative 1/4 times 2 squared. So this is the same as negative 1/4 times 4, which is the same as negative 4 over 4, in case you guys aren't great at fractions, which is just negative 1. Whoop, there we go. All right, next part, negative 1/4, x plus 2 squared. I only care about that part. X plus 2 squared equals 0. Subtract 2 from both sides, and x equals negative 2. It touches there, so it's going to go here, here, and it is indeed going downward. And there's my answer. And now what I would like to say is check your answers. Make sure they are correct. Let me go off the screen. If you pause it, you guys can check. Boom! That completes our lesson. It was a little bit tedious, but not too bad. But now, between last lesson and this lesson, you guys are able to graph quadratics, at least sketch them, using the intercepts, using basic knowledge of vertices, and so on. And then when we continue our next lesson tomorrow, which is on how to find the axis of symmetry, we'll be able to create even more accurate graphs, okay? We're just going to keep on building and building and building until you can graph these things perfectly in your head, and then check your answer with a calculator. All right, so until the next lesson, I bid you adieu.